Now, to learn how the tiny atoms behave, we turn to the study of fire and light. Darkness is the place to study fire. Before any atom can give off light, it must first gain energy. The hot gas flames excite the atoms we put into the flame, chosen because a few specks of those elements are enough to make bright color. Familiar red neon, mercury, hydrogen. Electrical energy, too, can excite the atomic colors. A few grains of table salt, sodium chloride, give the yellow flame, a good match to our small version of a highway sodium lamp. This spectroscope extends our sense of color. The narrow slit admits a line of light. The prism arrays that light, according to color, into many colored lines. I see a close pair of yellow lines, only a bony skeleton of the rainbow. A particular pattern of colored lines identifies an element. The spectrum is as good as a fingerprint, recording the colors emitted by a host of atoms all alike. Look at 4 fingerprints. These widely spaced lines were a puzzle for a long time. The physicists tried to match them with some internal state of the atom, a line for each state, rather like the notes of the piano. It just did not work. Finally, they had a surprising new idea. We can follow it by imagining a simple atom, really only a toy. Think of the toy atom with 3 energy levels, only 3 energy states in which it can exist. The lowest level is its resting state. First, let it gain energy to go up to the next higher state. When it drops back again, it gives off light. The energy the light carries off is the difference between start and finish. Every jump makes light of a particular color. Arranged in rainbow order, those colors are the spectrum of the toy atom. There is a tight match between the spectral lines and the energy level differences. That is the heart of the theory of atomic behavior we call the quantum theory. Watch once more. 3 energy levels. 3 transitions. 3 lines in the spectrum.
Okay, Ms. Redican here. We're going to take a further look at the particle level. So here we can see this is a hydrogen gas in this tube being excited by electricity. And you can see that electrons are jumping around and releasing energy in the form of light. 2 things to notice. 1, that the light is produced, watch here, it's produced when it jumps to a lower level. Yes, it gets excited, but it only releases that light as it makes that jump back down to the ground state or lower level. That's when it releases the light. The other thing to notice is that they're releasing different colors of light, and that's corresponding to the energy jump it takes. So larger jumps, let's take a look here. Right, we have one here. And when that jumps down a little bit, it's blue, red. But when it jumps a larger jump, you get purple. So the corresponding energy and the corresponding jump and the colors of lines that you get all go together. These are all hydrogen atoms, and you get this atomic spectra. This is its fingerprint for hydrogen, and we'll identify it. Okay, keep on working on your lab.